Okay, Assalamu alaikum shabab. Welcome back to the lecture. This is the first lecture to be recorded and to be made available for you. Today is Monday, the 12th of April, 2021. And tonight is the night of Ramadan, so I would like to wish everybody, inshallah, a Ramadan blessed with mercy, joy, and happiness. And may Allah accept your deed, ya shabab. Now, a few announcements as I promised that I will dedicate the first few minutes of from every single recording uh, for announcement. First of all, uh, the homework number 4, which was posted and made available for you on the Blackboard, which is, by the way, due very soon, I think this Saturday, um, is missing figure in problem number 1. So what I did, I updated the the homework sheet, and I uploaded it again for you. Okay, this is announcement number 1. Announcement number 2, I released the grade for quiz number 2, and I would like to ask anyone who has a problem, uh, would like to to revise the quiz, can always, send me an email or meet with me during the dedicated hours for during the class time. Okay. um, I will soon announce when are we going to have the quiz. My assumption is that many of you would prefer to have it probably at night because of because of Ramadan. But um, I think it will be very tough to coordinate the meeting. So I'll should make a decision by tomorrow and let you know. But I think I may go with the. I'm not sure yet if the majority picked the night or the afternoon, but it will most likely be during the afternoon time. If we manage to do it at night, I may send a questionnaire, whatever. It will be good. We will have one quiz, one time for everybody. And I think this is going to be healthy as well. Okay. But we should know about this, inshallah, soon. So let me, by this, I end the announcement for today and I start this lecture. By the way, before I start, it is already around 8:30 p.m. here today, and you can't see the backlight behind me because it is already night, and I probably this is too late for today, because if we assume that you're going to watch the lecture today and then you will come in the class tomorrow, ask questions, you should have had this lecture much earlier. But as I told you in the blackboard, I had some technical difficulties, so I got rid of it. Now we are good to go. Okay, so this is it. So let's get started. So last class, ya shabab, we stopped with external contracting rim clutches and brake, and we said that basically in this arrangement we will have the drum and here over there, and then around it somewhere we have a shoe which is being pushed to apply the brake. Now, one important thing, ya shabab, that I think I did not emphasize on very well in my past lectures, which is the coordinate system. So the coordinate system, actually, the accurate way to align your coordinate system is as such that the x-axis should be aligned with the pivot point. So if you have the pivot point right there, then this is the x-axis. And the y-axis will definitely be orthogonal to the x-axis, like this. Now, when you determine the x-axis, you should go and then measure theta 1, which is at the beginning of the frictional material, and then theta 2 at the end of the frictional material. Last class, not this class, I think the class before, we had an example of an internal break, and it was a long shoe like this, one here and another one there, which was solved in the from the textbook. And we said that we basically oriented the coordinate system such that this is x and this is y. And this is where I did not tell you this very clearly, that x was not only passing through theta 1, which made theta 1 equals to 0, which is very nice. It's helpful in the integration. It is actually, before you think about the beginning of the frictional material, you should think about the pivot. So x1, I mean, sorry, not x1, I mean x is passing through the pivot buoyant. That's what matters. And then y is perpendicular to it. Why is this very important? You will see it in the next example. So, what did we say? We said that, quickly, we said that things are a little bit reversed with external brake being arranged this way. If we have a clockwise rotation, we can see that the actuating force is kind of in the opposite sense. And that's why in a clockwise, we have a self de energizing. Self de energizing always have the plus or addition between mn and mf. If you do counterclockwise, the friction will help reducing f, and that's why we have the minus sign. So counterclockwise will be self-energizing. This is very important. We also said that there are minor changes in the signs and arrangement of a, f, b terms in the rx and ry, and you should be careful which one to go with. Okay, so these one are for the self de-energizing, and these one are for the self-energizing. And what you should know here is that the moment equations mn mf are still the same, as well as the torque equation, similar to the one we talked about in the internal brake mechanism. Okay, all right, now let's go to this interesting problem. Looks very simple, very interesting, but it will teach you something very crucial over here. It says here the block type hand brake. This is a hand brake. As you see, you'll probably imagine that this is your hand and you are pushing downward. In the figure has a face width of what? B is equal to 30 millimeter, and a mean coefficient of a friction F, which is 0.25, for an estimated actuating force of 400. So F is equals to 400 Newton. We want to find the maximum pressure on the shoe and find the braking torque. Okay, so basically we want to find PA and we want to find the torque. Of course, all dimensions in here are in millimeter. Okay, so what I want you to understand over here is the following. Okay, we want to find, if we have F, think about it this way. If we have, let me just give me 1 second to pull my note over here. So if we have F known, C can be measured from the geometry, and we know MF and we know MN, which are going to be function of the maximum pressure. We will probably be able to find the pressure from this relation. So basically, we can imagine that by saying that um, F is equal to, okay, F is equal to uh, mn minus mf divided by c. Then if we know mf, mn, c, and f, such that mf is function of PA and MN is function of PA, then we can find PA. Once we find PA, we can find the torque. Okay? There's no big deal about that. But so this is how are we going to plan the solution. But in order to find MA and MN, let me show you the equation over here. So I'm gonna clean this up just to make a clear place over here. So what is MN? MN, just to remind you, it is equals to PA multiplied by B, the shoe size, which is 30 millimeter, multiplied by R, which is the center from the distance from the pivot all the way to the center, multiplied by A, which is what, ya shabab? Do you remember this? Try to think about it while I'm writing the equation. And then we have sine theta A. And then the integral from theta 1, theta 2 multiplied by sine theta, then square d theta. Now, in the slide, I gave you the solution for this expressed um, as this. I said this is equals to PA BRA divided by sine theta A, and then this is equal to theta over 2 minus 1 over 4 sine 2 theta, and then, evaluating this from theta 1 to theta 2. Now, in the solution that I am going to provide, the, the solution was expressed automatically by integrating this, not by evaluating this, which is the same, right? It's the same. Now, what is MF? MF is equal to F, the friction coefficient, PA, BR divided by sine theta A, and then the integral from theta 1 to theta 2 multiplied by sine theta multiplied by R minus A cosine theta d theta. Again, in the solution, you will see that we are going to express this in terms of the integration, which is not a problem. Now, the the distance A, I ask you to think about it, is basically the distance from the pivot all the way to the center. Okay, the distance from the pivot all the way to the center. I'm going to show you all of these numbers soon. Now, also, you may look, so you see that the friction, I mean, the actuating force is in this direction and the rotation is in this direction. So this is probably going to answer the question in your mind when I was saying that F is equal to mn minus mf divided by c. So some of you might say, why did he do that? Why? Why did he assume it is minus when it is a plus? Because here we have a self-energizing. If the force is on the other side, we will have a self-de-energizing. You understand that? So here we have a self-energizing system. All right. Now, so let me go back to, I'm gonna clean all of this up right now, okay? I want you to focus on what I'm gonna show you next. So I'm gonna clean this, as I said, and now we see this integration limit. Whether you solve it, by substituting the integral right away, by integrating, it doesn't matter. What matters here is that what is theta 1, what is theta 2? Now, if you relate what I just said, that the coordinate system must be oriented such that x is passing through the pivot, then ya shabab, the coordinate system will be like this. This is x, you see it, and then perpendicular to it, I will have y. Now, I think you saw where I am getting to. What I'm getting to is that it wasn't a coincidence, it's true, that in reality, theta 1 will be right there. There is a little gap in between. And theta 2 is right there. So the common mistake is that someone will assume, like usual, that this is x, this is y, and that somebody would say theta 1 is equal to 45, and then what is theta 2? It's going to be equal to 45 plus 90, which is 135. So somebody by mistake will think that this is 135, which is wrong. Wrong. Yeah. So good. So now if we did this, so let me clean this yellow one. We don't need it. The green one is our coordinate system. So what is this angle then? Yeah. If I know this angle, okay, I know, look, ya shabab, I will clean it up again. Look at it. If this is if this is 45 and this is 90, and of course this line is 180. So how much left? 45. So this must be 45. Okay. Now the green line will pass through here. So what I can say, if I find this angle, which let me call it psi, for example, and this is x, then I can say that theta 1, let me write it here, theta 1 is equal to 45 minus psi. Isn't that true? I have the 45, I take from it that green angle, and what I left with is how much is this distance, which is from the green all the way to the first shoe, to the line of the first shoe over there, that little bit. So in that case, I would say that this is theta 1, which is equal to 45 minus. So if you guess how much is this, well, look carefully. This distance from here to there is 200. Yeah. And the distance from here to there is 150. Cool. So the tangent of psi, so tan psi is equal to 150 divided by 200. In another word, if I want to know psi, then I should take the tan inverse of 150 divided by 200. Cool. Now, if you do this, you will end up with theta 1, which is equal to 8.13 degrees. That little tiny angle. From x, you go 8.13, and this is theta 1. Okay. Now, so what is theta 2? Theta 2 will be 8.13 plus 90. Correct? That angle 90 is encompassing the shoe. But because we are measuring it from the green x-axis, we need to add that 8.13. So it is going to be theta 2 is going to be equal to 98.13. That's it. This is very important. Very important. So what is theta A? It is 90. That's a long shoe. So it is 90 degrees, and thus sine theta A is equal to 1, which is very helpful. Now, I told you that the solution that I'm going to show you is expressed in terms of the integral. So what did we do? We say A here is equal to 1 over 2 multiplied by what يا شباب? Sine square theta, and then we evaluate this from 8.13 to 98.13, which is equal to how much? 0.48. What is C as a like a variable. It is the integral of theta 1 to theta 2 for sine theta d theta, which is equal to minus cosine theta, and then this is 8.13 to 98.13, which is equal to 1.1314. You may ask question, what are these? For where I am going to use them? Well, here we come. So MF is equal to, as I said, is equals to F PA multiplied by BR divided by sine theta A, and then we have R minus, R, R C minus A A. What is this? Let me quickly bring up the equation for you. Okay, just give me 1 second. I'm pulling it out here from my note. So if I want to remind you that MF is equal to F, uh, I'm gonna make it a little bit bigger. So MF is equal to F BA multiplied by B multiplied by R divided by sine theta A, and then multiplied by the integral from theta 1 to theta 2 multiplied by sine theta, and then sine theta is multiplied by R, and then minus A cosine theta d theta. So if you look carefully over here, C is over here is the integral of what, ya shabab? Of sine theta, correct? So, and then you multiply it by r. That's why there is an r. R is independent of theta multiplied by c, which is the integral of sine theta. I've done nothing. Then here a, which is this one, multiplied by what? Cosine theta. So why is that? Because here you have sine multiplied by cosine, and then you can convert it into a cosine square. I mean a sine square. So which is half sine square, and this is where this term came. Okay, and when you integrate it, you just put it right there. I know maybe this isn't the most convenient way, but it is another solution, another way of solving the solution. You can still ya shabab, go and be comfortable by solving MF using the equation, which is F P PA. Oh, let me clean this. So F PABR divided by sine theta A multiplied by R cosine theta minus A over 2 sine square theta, and then you will have theta 1, theta 2. You can substitute these, okay? And you should be able to get the same answer. This is just a good exercise for you, okay? Now, so what is next? Well, if you do this, if you do this, okay, and then you substitute. So I'm gonna go here and substitute. Let me use maybe. Then I will get MF, which is equal to 0.25, that's the coefficient of friction, multiplied by PA, which is unknown, and then multiplied by B, which is 30 millimeter, which is 0.03 meter, multiplied by what, ya shabab? By the radius. Now, look, what is the radius? 150. So it is going to be 0.15. Good. Divided by sine 90, and then we multiply it by r and by a. So what do we have? If you recall here, we said r c, c is 1.1314 and a is 0.48. So we will have here this as R, which is 0.15, multiplied by C. C is equal to 1.1314, and then minus 0.25, which is what, ya shabab? This is not, this is something you should not know, which is A, we did not calculate yet, multiplied by capital A, which is 0.48. Now, the question, what is A? If you recall, we said that A is what, ya shabab? Is it's A is the distance between the pivot all the way to the center, right? From the pivot to the center. Where is the pivot? It is here. That's the pivot. Where is the center? It is here. So you need just to go and connect these two, and that's A. So what is this? This one again is coming from 150 and 200, and it is the hypotenuse. So A indeed is equal to the square root of 150 square plus 200 square, and this is where I told you when I was explaining it, there is a 2.25. So the 0.25 is actually coming from this. This is 250 millimeter, which is 0.25. So this is 0.25. Good, ya shabab. So if I do that, what would I get? I will get MF, which is equal to 5.59 multiplied by 10 to the power minus 5, and then multiplied by PA in Newton meter. That's what I'm going to get. Yeah, it's in a Newton meter, it's a moment, and there is a pressure inside it, which is PA. So what should I do? I should go to MN. MN has a parameter, which is, I'm going to call it B. This is the same one as the one I showed you earlier, which is theta over 2 minus 1 over 4 sine 2 theta. So what do I have to do? I have to substitute this, but be careful. I need to substitute this as 8.13 by divided by 180, just to remind you, because here this has to be in radian. You understand? Or maybe you will make a mistake in the calculation. So let me tell you this. Maybe I should not do that, and I should do this. I will put here 8.13, 98.13, and then right there, instead of putting theta, I will put theta by divided by 180. So comfortably, you can substitute theta in the sign as 8.13 or 98.13 while switching the degree mode in the calculator. But when you substitute them in here, you have to multiply by pi, divide by 180, and then you will get this term as 0.925. Shabab, it's very important to go and do this with your hand. Don't wait. Do it today. Okay? Now, what is MN? MN is equal to PA multiplied by BR multiplied by A divided by sine theta A multiplied by B, which is this coefficient. If you do this, you will get PA multiplied by B, which is 0.3 meter, the radius 0.15 meter, and then A, which we just calculated, is 0.25 meter, divided by what? Sine, which is 1, and then multiplied by 0.925, sorry. Let me make sure I write this very well. I don't want you to be confused. And maybe I should put it in another color. This is 0.925. You multiply this, and what do you get? You get this as 1.0406 multiplied by 10 to the power minus 3, but PA, and the unit is a Newton meter. Good, ya akhwan. I think I ran out of pages, so I'm going to add one over here. So what I'm going to do now, because, as I explained, this is a self-energizing. So I will have F, which is 400 Newton, equals to Mn minus M. What is this M? So Mf divided by C. So I have 400, which is equal to what? 104.06 minus 5.59 divided by what? C. Let's go and see what is C. C is the distance from the actuating force to the pivot point, which is 300 plus 200. So it is 500 millimeter. And if I divide it by 1,000, it's going to be zero point 0.5. Don't forget, this one and this one need to be divided by what? 10 to the power 5. That's why we have 10 to the power minus 5 in there. Okay. So when it is down, it's like dividing by 10 to the power 10 to the power 5. So multiplied by pressure PA, which will give you the first requirement, a PA equals to 203 kilo Pascal. That's the answer. Good, ya shabab. So what is the torque? The torque equation is F PA multiplied by B R square multiplied by the C, that factor I calculated, over sine theta A. And if you substitute everything, because you know everything, you will get a torque of 38.76 Newton meter. Okay, that's it, ya shabab. So this is the solution. This is a problem from the textbook, but it is really interesting one. Okay, Shabab. So the next topic that we're going to talk about is a side topic, okay, which is an interesting special case. So one of the special cases that can be applied in external contracting rim is to have this symmetric uh, kind of a breaking, in the sense that if you put the pivot this way, this is the pivot, and it is aligned in this like horizontal, then it is located in a symmetrical way with respect to this side and that side. So the pivot is in the middle and everything is symmetric. So, and this is gonna also place the moment of a friction forces about the pivot become zero. So, what is that? Is that so? We said here that a special case arises when the pivot is symmetrically located and also placed so that the moment of the friction forces about the pivot is zero. So we get a zero moment in there. And so what happened is this. We will also realize that this symmetry going to result in an equal wear along the radial line. Yeah, so along an angle, you have the same pressure because of this symmetry, and then the symmetrical pressure, and then you get the same wear. So that's why the wear analysis of this kind of break is interesting, and this is what we are going to talk about. So if we assume that the wear along the radial direction, so as a function of theta, is w theta, and w0 is the horizontal component of the wear of all positions. So at any position, let's say you pick this arbitrary position, the wear along that position is w theta. But if you measure the wear along the horizontal, it's just like a vector, it is w0. So this is the horizontal component of the wear. K is a material constant, which is probably similar to what we did with the journal bearing when we studied their wear, and we said that um, um, uh, we have a K, which is a material constant, and it is defined as the wear factor. And B is the pressure. V is the rim velocity, which, by the way, along the rim is the same. So, because this is related to the RPM, so whenever you are right there, any point along that rim has the same velocity. T is the time. So we can have an expression. I'm not going to go through the derivation, which relate the pressure distribution kind of at any angle is equal to the horizontal component of the weir, W0, multiplied by cosine theta divided by K V T. Now, what happens is this. If you look at this, ya shabab, you will see that arguably along any radial direction, that value is constant. And in another word, because at every point along the radial direction or along the radius, you will have the same pressure. At a point, you will have the pressure. You will have the same velocity, and basically, time is passing in everyone the same way, and you will experience this that the ratio over here will become constant. That's why we call this constant multiplied by cosine theta. So it can be shown that this can be related to the maximum pressure, okay? And by doing so, okay, we can now express the reaction forces at the pivot as well as the torque. So what is important before we do this for this special case is that the distance A over here to the pivot, which is from the center as usual to the pivot, that's A. I just marked over it, is chosen by finding where the moment of the frictional forces MF is zero. That's what we said, that MF becomes zero. And then you have to be very careful because mislocating the pivot, that pivot point, makes MF0 about a different location. And once MF0 become, MF becomes zero at a different location, okay, the lining, the brake lining, which is the shoe material, will adjust its local contact, okay, um, uh, local contact pressure through wear. So it will tend to wear in an unsymmetrical way in order to compensate for that shift because it is imbalanced right now. And what happened? That unsymmetrical wear means the shoe will have to be retired. This is the problem which we sometimes face in our car, although our car is are not uh, does not have our cars do not have a brakes like this, but if you miss the balance of the shoe, you will end up pushing in one side more than the other, and then you lose the shoe in one side while the other side is still healthy. Okay, so how do we determine A in the location where the wear becomes symmetrical? We don't have this asymmetrical wear. Is using this equation. So I'm not going to go through the derivation. This is the equation. And then for the pivot, I mean the distance A, and this is the reactions, and this is the torque for this configuration. This is very special case. Okay, one case, and that's it. So what are we going to do? This is the last part of this lecture, is going to another type of a clutching and braking, which is a flexible clutch and brake bands, which are, by the way, used in power excavators and hoisting and other machinery. So don't think that such braking system is like not used or not very common. So in this system, what I want you to understand a few things is that we have a drum which is rotating, and there is a line over here, a pivot, in which we put a cable surrounding this drum. Okay. And what happened is that while the drum is rotating, this cable will stay in touch. And the moment you want to push on the brake, all what you need to do is to push B2. Now, why do we have B2 and B1? That's the question, right? Well, very simple. Because P2 is what you think you are applying. Yeah? But when you apply that force downward, this band will push against the drum and it will try to rub against it to stop it. That's how we dissipate the kinetic energy, the rotational energy. And but because there is a friction, P1 will be kind of subjected to your force in addition to the force of the friction. So, two, that's why in reality, the relation between P1 and P2 is not linear. So, what happened? The relation between P1 and P2 is expressed as the natural logarithm ln P1 divided by P2, which is equal to F, the coefficient of friction, and the angle phi. What is the angle phi? Just to show you over here, the angle phi is the angle which the cable covers around the drum. Yeah. So in this case, you can see it starts from here all the way to here. But what happened? What happened if the cable in the green cable goes like this, for example, straight? Well, the angle will start from here, the yellow, but it will end here. So it depends. It depends. If you push the cable, the blue one, like this, then the angle will start from here all the way to here. It depends. Do you understand? So don't ever think it is fixed. Now, if you take, of course, the exponent, you will end up with an easier way to calculate the P and P2. So we'll have P2 over B1 over B2, which is equals to E to the power F phi. What is the torque? Torque is going to be related to the difference in the forces multiplied by the diameter over 2. What is the diameter? This is the diameter, which is the radius, basically, right? It's like there are couple moments, I mean couple forces, right? So you will see their difference multiplied by d over 2. The pressure which is generated, okay, I'm talking about the pressure, okay? The pressure generated is equal to what? Is equal to P capital divided by B R. B is the width and R is the radius, which is equal to 2 B capital divided by B by D. What is B? Is the at any given point over here, the pressure, okay, the capital P is basically the tension, okay, the instantaneous tension at the at this band or cable. Now, what is the maximum pressure? The maximum pressure is, remember, this is the pressure which is exerted by this cable or the band on the drum, which is PA, as it's equals to twice as P1, very expected. It is a function of P1, not P2, because you will see in the example that we're going to solve next that P1 might be way bigger than B2 because of this frictional forces that are pushing it further, divided by P divided by P multiplied by the diameter. So in this example, this is going to be a short one. If we have this arrangement given in millimeter, of course, So we have a drum with a diameter equals to 250 millimeter, and the drum is being, you know, acted upon by this brake band system, which is pivoted right here. That's the pivot. This distance from here to there is 200, and the actuating force, where presumably, I mean, we are thinking here that you are the one who is pushing this down. Remember, when you push down, this rotation is going to slow down. That's what happened. So how far is this? This is 250 from the cable. Remember, this is P1 and this one is going to be P2, correct? And the distance from this point where the cable is being pushed to the end over here is 125. So what were we given? The friction coefficient 0.3, the actuating force here is 400 Newton, and B, the width is 50 millimeter. And what do we want to find? P1, P2, and the torque. So let me show you how are we going to solve this. The first thing, ya shabab, is that you should understand that the angle which covers phi is this. It's going to be, clearly, ya shabab, it's going to be this until this. This is phi, correct? Yeah, that's it. Now, the question, what is what is this angle? Yeah, we know that this is this one, ya shabab. How much is this angle? So in the solution, we are calling it, let me make it here clear, this angle, we're calling it alpha. Why? Because I know that alpha, and let's call this one beta. So alpha plus beta is equal to 90. If I find alpha, I will know beta, and then I will add this beta to 90 and I will find phi, correct? So how can I find this? Well, listen carefully. First of all, you should know that from geometry, this is supposed to be the tangent. And if it is the tangent, the radius from the center to the tangent will make angle 90, correct? And if I have 90, and so this is a right triangle, very simple, right? And it is a right triangle with this distance equals to 200. Yeah. And this one is 90. So, and what is this distance, ya shabab? Let me, I will clean it up. Okay, this is very important. Whoa, what did I do? Yeah, I put a geometry over there. So let me show you this clearly, ya shabab. This is the radius. This is angle 90. And this is 200. And this is my triangle. Now, what is this distance? 200. The same as this one. What is the other one? The other one is half of the diameter. If the diameter is 250, then this one is 125. So, what is alpha? What is alpha, ya shabab? Alpha is going to be equal to cosine inverse of 125 divided by 200, which is going to be equal to 51.32 degrees. So what is phi? What is phi? Well, I told you, you can find this angle and add to it this angle. But in a more straightforward way, let me clean this again. In a more forward way, if this one is 51.32, okay? What is this, Hishab? This angle from here to there. All of this, 270, right? So phi is equal to 270 minus alpha, which is equal to 270 minus 51.32, and this is going to give you 218.7 degrees. That's it. Now, what is F phi? It is, how much was the friction? 0.3 multiplied by, be careful, 218.7 multiplied by over 180, and this is going to be 1.145. Remember, whenever you multiply degrees by numbers, friction, length, then they must be in radian. Okay? Now, so what happened is, look, if you take the moment about point P1, this is P1, this is where the tension P1 is, and you say this is equals to zero, what you are going to end up with? You're going to end up with this one going in this direction, and with this one, what is it, Yashabab? And then this one is acting upward, going in this direction. Is that correct? Be careful. Be careful. Let me repeat this again. I don't want you to misunderstand it. If I cut the cable, what would I get? The cable here, sorry, in red, the cable will have a force downward. So the one that opposite will have a force upward. So in reality, this is the arm. Okay, this is the point where I'm taking the moment. I have F, which is acting downward, and I have the green one, which is acting backward, upward, P2. So what I'm gonna end up with F multiplied by 125 plus 275, which is equal, because there are two moments only, they are equals to each other, which is equal to P2 multiplied by 125. So what is B2? B2 is going to be equal to F multiplied by 125 plus 275 divided by 125. And this is going to give you P2 as how much? 1280 Newton. Now, the question, what is P1? Correct? What is P1? So P1 is going to be, oh, I have the solution right away, so let me add another slide over here. So P1 will be equal to what? It is equals to P2 multiplied by E to the power F phi. I know everything. So I have 1280 multiplied by the exponent of F. By the way, we found F phi, right? And from the previous slide, F phi was equal to 1.145. So how much is this? It is going to be, oh, I'm sorry, Shabab. This isn't the exponent. This is only the power. So I need to clean this. So it is equal to E to the power um, 1.145. And how much would I get? I will get, ya shabab, listen to the number, 4022 Newton. That's that's a lot compared to P1, to P2. Okay, so what is the torque? Torque is equal to P1 minus P2 multiplied by D over 2. And this is going to give me 4022 minus 1280 multiplied by the diameter, which is 250 over 2. And this is going to give you 342,750 Newton millimeter, or it is basically 342 Newton meter. That's it, ya shabab. That's the end of the lecture. So we'll talk about the frictional contact axial clutches, inshallah, in the next class. Thank you so much, and talk to, inshallah, see you next class, ya shabab.